This is 3.1, all about graphing systems and substitution. So when we talk about systems of linear equations, we just mean that there are two equations that we're working with, and then those lines have three different options for how they can interact with each other. Okay, so we're going to today talk about graphing these and then using substitution to figure out what their solutions are. Okay, so this is kind of blurry. The image in your packet is much clearer. This concept is that if we have two lines in the coordinate plane, there are three options. Those lines could intersect at a point. Those lines could be parallel, meaning they would never intersect, or they could be the same line, meaning they're overlapping. Okay, and so some names to get familiar with. If the lines intersect at one point, they are consistent. That system is consistent. They're also an independent system, and their solution is an ordered pair. So these two lines that meet at the point, let's see, 2, 4, 6, 6, 4, their solution is the ordered pair 6, 4. These parallel lines have no solution, they never intersect, and then these lines that are the same, they're overlapping, they have infinitely many solutions. Okay, no solutions, those systems are known as inconsistent systems. Systems that overlap are consistent and dependent. So here's an example. We're going to solve these by graphing. We're going to graph these by hand, okay? Then we're going to verify with Desmos. So graphing by hand, we should be comfortable with this. I'm going to graph this bottom line first. Y equals -5/2 x minus 8. I know that my y-intercept is down here at -8, and then I can use my slope of -5/2 for rise over run, up 5 over 2, up 5 over 2, up 5, 1, 2, 3, 4, 5 over 2, okay? And then I'm going to use my line creator so that it's a nice straight line. And then to graph my top line, 2x minus y equals -1, I'm going to transfer this over to slope-intercept form. And when I do that, it's going to be y equals 2x plus 1. And then I can graph it very easily. The y-intercept is up at 1. Using my slope, I can go down 2 over 1, down 2 over 1, down 2 over 1. Etc., etc. I can use my line tool to create a nice line going through these points. I know that these are rays, but pretend like there's an arrow on both sides. And then I can see that these lines intersect at this point. So to solve this system, I'm going to list the solution as an ordered pair, x comma y, where x is -2 and y is -3. And I'm going to verify with Desmos. Here are my two lines. Where do they intersect? They intersect at -2, -3, so we are good to go. Okay, example 2 asks you to use Desmos or a graphing calculator to graph each system. If you have a TI-84, I will link a separate video that can show you how to use that to find intersections. And then we're going to describe these systems as consistent and dependent, consistent and independent, consistent and dependent, or inconsistent. Okay, so this first system, let's take a look at it. Here it is. So we see that this system intersects at one point, meaning they're going to be consistent and independent. Consistent, independent. The second system, let's take a look at it. It looks like they're overlapping the same line. Okay, so as I'm removing one line and putting it back, you can see they're the same, meaning these are going to be consistent and dependent. I kind of remember it like if they're the same line, then they like depend on each other. Okay, so that's how we can use graphs to solve systems of linear equations. This is substitution. This is one of my favorite concepts in all of algebra. Okay, the concept is step 1, we're going to solve one equation for one of the variables. Usually we like to solve for y. Sometimes we can solve for x or whatever letter. We're going to substitute the expression into the other equation to replace the variable, and then we'll solve the equation. That'll make sense once we go through an example. Step 3, we will substitute to solve for the other variable. Okay, so example 3, use substitution to solve the system. I see that I have this y by itself, so what I'm going to do, I'm going to take this expression that it's equal to, and I'm going to plug it in to the other equation wherever I see y. Okay, so 2x minus, instead of writing y, now I'm going to write in parentheses 3x plus 5. I'm going to put parentheses because it'll cut down on the sign errors that I could make. That is equal to 10. And so now we have all x's, and we're going to be able to solve this for x. 2x, distribute this negative, 2x plus 3x minus 5 equals 10. Combine like terms. 5x equals 15. X equals 3. Don't stop here. Remember, we need an ordered pair. So we're going to use the fact that x equals 3 and put that in for x in the bottom equation. You could use either the top or the bottom equation, but the bottom one's already solved for y. So it's a little bit easier. Y equals negative 3 times 3 plus 5, meaning that y equals negative 4. Our solution is going to be an ordered pair. The ordered pair will be 3, negative 4. And that is how I want you to write your solutions, as an ordered pair. Pause the video, try these two. Okay, hopefully for this first one you got that their intersection was at 4, negative 1. And then I'm going to solve out this second one so that you can see what it looks like. Okay, so to use substitution, neither of these has y by itself. So I'm going to move around this top equation to get y by itself. So if I can add y to both sides and then subtract 27, I'll end up with y equals negative 6x minus 27. And then I'm going to use that and plug it in for y down here. 2 times negative 6x minus 27 equals negative 12x. Oh, I'm going to rewrite that. Equals negative 12x plus 54. Distribute negative 12x plus minus 54. Goodness. Can tell it's the end of the day. Minus 54 equals negative 12x plus 54. At this point, you should notice that something's kind of fishy, okay? But say we don't notice that. Let's add 12x to both sides. It means we're going to end up with negative 54 equals 54. Is that a true statement? No, it is not, meaning this system is going to have no solution. Okay, so when we graph these lines, they're going to end up being parallel. There's no solution. That's all I have for you. In your notes, there's a little bit of information about using Desmos or a TI-84 to do this for you. Take a look at your practice and let me know what questions you have.